Hey Valley Metal, welcome back to another G67 math lesson. Tonight we're going to be working with order of operations. I'm going to throw a couple of new things at you. Before we do that, let's start off with a new trivia question tonight. Tonight's question, what is the Queen of England's name? Many of you might know the first name, but I'm not sure you're going to know the rest of it. Alrighty, tonight officially our target is I can use the order of operations with grouping symbols to multiply, divide, add, subtract, and simplify expressions. I'm going to throw negative numbers in there as well. All right, let's do this thing. Can you evaluate this expression? Holy shnikes. You got to be kidding me. Let's put this problem on hold for a minute and let's take a look at Pemdas. In 6th grade, we talked about Pemdas with parentheses. You know, in 7th grade, we're going to start to refer to it as GMDAS because it can be really any of these grouping symbols. If you still want to think about it as PEMDAS being all brackets, that's fine, but GMDAS kind of stands for any of these grouping symbols. So what you do is you do your normal order of operations, but you're going to have multiple sets of brackets, and you basically just work from the inside out, like my little flashing light is saying down here. So let's just take a look as I go through this one. First of all, we have to take and substitute in 3 for these x's here because it tells us that x is equal to 3. So when we do that, we have this new expression, and it looks really super complicated. But let's work from the inside out. Here's the innermost set of brackets. And inside that, we have multiplication and addition. If we follow the order of operations, we have to do that multiplication first. We do the 2 times 3, and we get 6. But we have one other operation in there that we have to complete in the inner parentheses first, and that is the addition. So our next step then would be to do that. We're just going step by step. Look at how much simpler our expression has got. All right, now we've taken care of everything inside this set of parentheses. We'll work our way out to the next set. Now we're going to have 3 times 11. So we'll take care of that. And that becomes 33. Now we've got rid of those inner parentheses. Now we have one more set of brackets where we have 3 times 33 we have to take care of, working our way from the inside out. That gives us 99, but we still have that quantity or that value to square. So if you take 99 squared, it is 9,801. It looks really complicated, but if you work from the inside out and you follow the order of operations, you can do this. Let's go back to this holy shnikes problem, and let's just get rid of Chris Farley for a minute and look at the way you would go about doing this problem. I think I'll put a screen in so we can talk our way through it. All right, x is equal to 5, and here's this big complicated expression. So the first thing we need to do is, if this is the case, you need to substitute in the value for x. So when I substitute that in, the x here becomes 5, and this 3 times x, or 3x, becomes 3 times 5. I just put in 3 times 5. The 5 becomes the x. This is for multiplication. All right, now let's take a look at it. We have to work from the inside brackets, the smallest set of brackets, which are these inside ones, and work out. So once again, we have multiplication, we have an addition problem. We have to do the multiplication first. That's in the order of operations. So 3 times 5 is 15. We still have the addition to do inside those brackets before we can move out. So we have to add 15 plus 12. And when we do that, we have 27. Now we're into the next set of brackets where we have to add 3 plus 27. Notice this is not multiplication. There's an addition sign there. So we take care of that set of brackets, and we get 30, the sum of 3 and 27. Now we have to multiply 5 times that 30 to get 150. Step by step, work from the inside out. I'm going to have you try a problem right away. A little more simple, but you go ahead and pause and give this a shot. All right. Did you work from the inside out? Did you remember to use GMDAS? All right, if you did, you worked from the inner parentheses. 1 plus 1 was 2. And then you did 2 times 3, which was 6. And all you had to do was square the 6 to get 36. Bet you got that one right. Let's try something a little bit harder. Here we go. Give this one a go ahead and pause the video and try this one. Okay, once again, did you work from the inside out? If you did, you would have started with 6 minus 1, and that's 5. Okay, the next set of brackets is quite large. There's a lot going on in there. Well, inside those brackets there, you have to go to exponents next. So 3 squared becomes 9. Now you've got multiplication and addition. You have to do the multiplication. 5 times 2 is 10. You're still within those brackets. You have to add the 10 plus 9. You got the 19. Now you can go to the outside brackets where you have to multiply everything by 2. You got 38. Nice work. All right. There's always a yeah, but. Yeah, but what if there's negative numbers? Let's give it a shot. This is a pretty complicated looking problem, right? But let's just work through it step by step. We don't have any values to substitute in. Here we've got all the values present. We've got multiplication and addition, but we've got a negative number here and a negative number here. So let's start with the inside brackets right here with this set. There's nothing we can do here. It's just -1. But this one has some things. So we have to do the multiplication before the addition. So now 9 times 1, that's just 9. But we still have 7 plus 9. We have to finish that out. So if we add 7 and 9, we have 16. So now I've gotten rid of that set of parentheses, but I've got 16 times a -1, and that's in this next set of brackets. Remember, we work from the inside out, so we have to do this first. Well, 16 times a -1, that's a negative times a positive. That's going to give you a negative answer, so you have -16. Now you have -7 plus that -16. Well, a negative plus a negative, that's a negative. It's like you spent $7, that's a -7, and you spend another 16, that's a negative number. So 7 plus 16, you have a total of $23 that you spent, or that you're in the hole. So it's a -23, a negative plus a negative. Okay? All right, your turn. Give this one a shot. Pause the video. Try working with some negative numbers. Yeah. Sorry about that. Go ahead, give it a shot. All right. Working from the inside out, you have to deal with multiplication first. So 9 times 1 is 9. So now you have 7 minus 9. You still have to take care of that. That's going to give you a -2. So now within this next set of brackets, you have a -2 times a -1. A negative times a negative is a positive. That doesn't mean 2 wrongs make a right, but a negative times a negative is a positive. So -2 times a -1 is a +2. Now you have a -4 times a +2. That's a -8. How'd you do? Nice work. You solved your first order of operations problems using negative numbers. We're going to practice lots of these in class, but I want to give you some exposure to it in that first try or that first look by yourself. Here are the ticket to the show problems. Remember, work from the inside out with the different brackets. I can see I forgot a bracket here. Fix that real quick. There we go. All right. The trivia question for tonight. What is the Queen of England's name? It's kind of interesting. I did not know this. I had to look it up. Queen Elizabeth was born on April 21st, 1926. Her full name at birth was Elizabeth Alexandra Mary. And she was born of the Royal House of the Windsor. Therefore, Queen Elizabeth's last name is Windsor. Interestingly enough, she would have been born earlier, like in the earlier 1900s, she would have had a different last name. It appears that prior to 1917, the members of the British royal family had this other name, Saxe-Coburg-Gotha. But who is it? King George V changed that because there were some negative feelings towards Germans after World War I in England, and so he changed it to the House of Windsor instead of this House of Saxe-Coburg-Gotha. Not even sure if I pronounced that right, but it's kind of interesting. Anyway, Windsor. Have a great evening. Thanks for listening. Bye.